Hello, the internet. So this is a video about smart switches, and this particular smart switch is the TP-Link Casa. They're not paying me to tell you about their smart switches. These just happen to be the ones that I was installing in my house, so these are the ones I'm going to show you. They're pretty okay. They do a good job. They work with Alexa, and they also work with Home Assistant if you're using Home Assistant. So they're pretty decent little switches. And the ones pictured here are a three-way kit. And a three-way switch, if you're not aware of what that is a situation where you have two light switches that control the same device. Now the actual demonstration that I'm going to show you, which by the way is going to be in slideshow format because I didn't have a very good camera situation to be able to record live video feed of me actually doing the installation, but I did take lots and lots of pictures, so I'm going to take you through the process using those pictures and just talk you through the whole thing, and it'll be pretty it should get you where you need to be. So before I start, I want to let you guys know I am not a certified electrician. And I live in the United States. So what that means is two things. First of all, if your wiring looks way different than mine and you're in a different country, please double check things. Don't burn your house down, okay? And two, you know, while this has worked for me several times over, I've installed these things on probably, I don't know, God, I've done 20 of these in my house now at least. Just tons of these things. I've done two ways, three ways. I've done the three ways. I've done the normal standard single switch. I've done dual switches for like a fan and a light. I've done dimmers. You name it, I've done it now. So I'm pretty confident that my method is going to work. However, I've only ever done it in my one house, which means if your house looks different, you should probably research that a little bit more rather than just, you know, blindly going forward. Another thing I should mention is you're going to require something called a neutral wire. It is a thing that most homes past, I think, 1985 per my research have, but you're going to want to double check that you have one. If you watch the video and you get to the point where I'll demonstrate what the neutral wire actually looks like, but basically it is a white wire that is behind your light switches and it is not used. It's capped off. It's basically bypassed. And so when you hook these up, you're going to need to run a cable from that to your switch. And you'll have everything you need in the box, and I'll go over that. It's really easy to do, but if you don't have that wire, just be aware these switches will not work. I have heard that there are smart switches that do work without the neutral wire, but those smart switches may be limited in functionality compared to ones that have the neutral wire. Being that I'm not an electrician, I'm not 100% sure why it requires the neutral wire, but it does. And it's part of the instructions. So you're going to want to have that and make sure you have it. And if you don't have it, I'm not sure if that's something you might be able to call an electrician and get them to add such a thing, but I'm not sure what you would do in that case. In my case, I do have it in most of my switches. I will talk about later a case where I found a situation that I did not have one, and I'll cover what I did there. But moving on, we're going to talk a little bit about the tools you might want to have in order to complete this job. So right off the cuff, there is two tools you're definitely going to want to have. One is a Phillips head screwdriver, and the other is a flathead screwdriver. So the optional stuff you're going to need is a multimeter, possibly. It's a really good idea to have one of these. They're pretty cheap. You can pick them up on Amazon or any hardware store, possibly a Lowe's or something if you have one of those nearby. It'll tell you if you've still got power, and that's what we're going to use it for, is to make sure that we're not going to kill ourselves. Just to double extra, triple check, you know. You're also going to use wire nuts. You should get a bag of those with your switch, so you shouldn't have to worry about it too much. This bag actually came with my switch, but if you don't get a bag of those, you're probably going to want to pick some up. This is a pair of wire cutters. Really good idea to have these in case you need to trim back some excess wire. You're going to see later that pushing these wires back into the back into the wall can be a little bit challenging, and so cutting back excess wire might be helpful, although you do want to proceed with caution on that. You don't want to cut so much wire that you make it hard for yourself to wire things up or change things if you want to later. So definitely do leave yourself some slack. The other thing those are important for, though, is those little wire nuts. If the wire, because it generally will wrap around a screw in its default configuration on your normal switch, you'll see that later. If you're in that position and you straighten that out, maybe that little screw, the piece of wire that was wrapping around the screw, will be too long for the wire cap, and pieces of it might stick out the bottom. If that's the case, trim it down, because you do not want to have any bare wire exposed, especially on your line wire, which is also called your hot wire, where your electricity comes in at, because if that shorts against something else, it could cause a fire or all kinds of bad things. So definitely make sure you trim it down and that all the wires are covered completely by that wire nut or wire cap or whatever. And then a pair of pliers is always good to help you kind of pull your wires back into shape. If you've got them wrapped around the screw, you'll use them to pry the wire off the screw a little bit, maybe pull it back into shape if they're bent up or whatever. These wires in your house wires are not like normal wires. They're not going to be extremely pliable in the way a normal wire would be. They'll be bendy, but they won't be like a normal cable that you hook up to, you know, your outlet. They're not going to be like really flexible. They're going to be kind of stiff and rigid. And so you're going to want a pair of pliers to help you move them around a little bit. Just make sure when you're using the pliers on them, you don't cut into the insulator. And then also these heavier duty sort of adjustable pliers, adjustable wrench / pliers, whatever. These are really, really good to have too, especially when you're working with the even heavier wires, because these needle nose pliers are good for straightening wires. These are good for pulling wires out of places. You'll notice that when you open yours up, maybe your neutral wire's crammed way back in the back and you've got to kind of finagle it out of the, you know, box a little bit. Those pliers will help you a lot with that task. And then these wire strippers are really good. So what I noticed is that when you get normal, like if you have a house that you had built, or you moved into a house that somebody else built and nobody's opened those switches up lately or messed with them yet, they may still have builder spray paint all over them. And so like the ground wire, for instance, is normally a bare copper wire. At least in the States it's like that. Usually it's a bare copper wire. I guess sometimes it's green, supposedly. I've never seen it that way, but usually it's a bare copper wire. Anyway, so that bare copper wire will sometimes be covered in painters, builders' chalk paint, because they just spray it down and don't, you know, bother to clean it up or cover it really well when they do it. And so if that's the case, you can use those wire strippers to scrape a little bit of that excess paint off of there if you're worried about getting a good strong ground. Also, if you accidentally strip back too much of your wire with the cutters, you can always cut some of that insulation off using the wire strippers. So it is a good idea to have those tools on hand. Fortunately, none of those things are very expensive, and you can pick them up at any hardware store or probably order them in a kit from Amazon. Not too bad. So the next thing we're going to talk about is, this is an actual what you get in the box kind of image. So just so you know what you're going to be working with. There aren't really any instructions in the box, at least not in my case. I didn't see any instructions to speak of, for instance. Really the only instructions they had was how to pair it with their little app or whatever, which I will give you a very brief demonstration of at the end of the video. But basically, you just get this, and you're expected to kind of follow what you see there and hook it up. And so fortunately the wires are pretty clearly labeled. You can see here it's got neutral and ground and all that next to it, and they're color coded. So yeah, it's pretty straightforward. It's not really bad at all. Go forward. All right, so this is a picture of the switch from the front. And so this guy here that's wrapped around it, this is a wall plate that comes pre-attached. You're basically going to pry this off with a screwdriver, and I'll show you that later. The first task that we have on hand is to disconnect power to our room that we are going to be working out of. Remember that working on your house electrical system is dangerous, and in fact can cause injury or death, so please be very careful and make sure you turn the power off to your room. What I recommend you do is go to whatever switch you're going to work on and switch it so that the power is on, so that whatever light it's hooked up to has power going to it. And then go back into your circuit box, which is usually either in your utility room or in your garage, and you're going to flip that switch off for whatever room it is. Then you're going to go back into the room where that switch is, and you're going to look at the light and make sure that light is in fact off. Okay, so once we've covered that, we're going to go ahead and pry that faceplate off of our switch now. And so what I'm demonstrating here, you can see on this side there's this little groove kind of etched out over here. When I originally did this, I thought, push the screwdriver in on that side, because that's the side that it's demonstrated as being the release part. Basically, if you want to pull this off the wall later, you would cram a screwdriver up underneath that groove there and pry it up. But when you're initially installing the switches, I find that that's very difficult to do, and I was really frustrated with it. And so my wife goes, why don't you just come at it from the other direction? Go from the top. And I went, but the groove isn't there. I'm going to break it. And she goes, just try it, because that's what I've been doing, and it's been working for me. And I said, okay, I'll try it. And sure enough, the wife was right. I popped it right off. One thing I do recommend, though, is you can see I've got it against a surface there. In that case, I think it's a padded couch. Definitely do that, because when you pop that off, it's going to shoot off, and you may, if it hits something hard, crack the faceplate or something. Another thing to note here, that faceplate is only good in the case where this switch is going to be mounted in the wall by itself. If you're going to be using a dual switch, such as a fan and a light, like this, you're going to want to reuse this faceplate here. Okay, so be careful to make sure you keep your screws in your faceplate. And also note that if you have these sort of paddle switches like this, you can reuse this faceplate. If you have standard switches, the old school little finger-shaped toggle switches or whatever, those kind are very obviously going to not work well with this particular design, and so you may want to go down to a local hardware store and find new faceplates for your walls if you have that situation. And here's a picture of it with the faceplate removed. So all I've done is remove those 4 screws and just taken that faceplate off here. And so the next picture is the switches extended from the wall. I've just basically unscrewed them and pulled them straight out. And you can see here that these are hooked up sort of differently. And so basically what's happening here is this is your line wire, and your line wire is your hot wire. That's the wire that's going to your circuit breaker. This is your load wire. Your load wire is going out to the device that you want to control. This is the other load wire. You'll notice that one is red. That may not be the case for you. They may both be black, but basically the reason one is red and one is black is so that you can differentiate in the wall between which one is controlling the fan and which one is controlling the light. I don't actually know which is which, but as long as you hook them up back to the same switch where they came from, you should be fine. And to that, I'm going to go ahead and recommend that you only do one switch at a time, so that you make sure the wires that came off of one switch go back on the same switch that you put them on, so you don't inadvertently switch which switch does what. Because if you do that, you're just going to throw yourself off. And I mean, it'll still work fine, but it might get difficult to, if everybody's used to it being the left switch is your fan, then you're not going to want to change that, right? I think in my case, it's actually the right switch is the fan and the left switch is the light. Anyway, so this bare copper wire here, these are your ground wires, okay? And each one of these are going to this, this little ground screw here, okay? So a lot of the wires on this particular switch, in this case, are shared. And even in my house, they're not all wired exactly the same way. So this design is actually kind of different than some other ones that I've seen. So some other ones I've seen is this line wire here is actually connected to a central wire, and then it's forked off of that wire down here somewhere, and there's a separate wire going up to each screw. This is probably the first one I've seen in my house where it's actually behaving this way, where it actually sort of bypasses or goes through this switch here or this screw here, and then gets punched down into the back of this switch over here. And you can see here what they've done is they've actually shaved this wire down, leaving a bare spot in the middle such that that connects this wire, and then they've let it continue on as one unified wire to this other switch. So we're just going to cut that off at the screw here after we disconnect it, and I'll show you how we do that. But before we get into that, we're going to look at multimetering, so don't touch the wire just yet. So this is a top-down view of these switches, and basically you can see here that wire in the background kind of coming off, and you can also see some of that paint I was telling you about kind of on these wires here. So you can see that this bare copper wire technically looks a bit painty and white, but it is in fact not shielding or any kind of shielding or insulator. It is simply paint that has been sprayed on from when the painters just sprayed a bunch of junk on my wall. So that's that, yeah. And here's the final image of this, and this is a very good look at this wire here as it comes in and then wraps around this screw and comes back out, and you can see your ground wire hooked up here, and you can see this load wire. The wires that go to the actual light or fan or whatever device, they're called load wires, and these are the ones that are only powered when the switch is active. And then the line wire is the one that's hot no matter what. That's the one that's only going to be switched off when your circuit breaker is off. And that's the one that will kill you if you touch it when the circuit breaker is on, or could kill you anyway. And to that effect, we're going to look at a multimeter. And so this is the part where I live in the United States should be pretty apparent to you, because if you live in other countries, you may have a different electrical system with a different setting. So in the States, we use 120 volt system. And so what we're going to do is we're going to hook our multimeter up. Now you see I've got this, and it's kind of, I'm a little disappointed in the quality of this picture here. I guess I caught a flash or something here, but it doesn't have the markings as visible as I would like. But you can see that this red lead here is hooked up to this volt, ohm, and then milliamps plug. So there's a red plug here, and then there's a common plug here. That's what I've got my black plug hooked up to. You've also got this 10A DC, 10 amp direct current plug, I guess. And that one is, we're not going to use that one in this case, okay? If you're in the States and you're using a 120 volt system, you're going to 120 VAC, you're going to put this on the 200 here. And if you're in another country where you've got a higher voltage or whatever, you're going to put it on the 600, okay? And then what we're going to do is we're just going to gently touch the ground wire first. We'll just stick it to the ground. You can either touch the screw or you can touch the bare copper. Of course, that's only in the case that this copper is still hooked up to the screw. If not, just touch the copper. And then you're going to take your other lead, your red lead, and you're going to touch it gently to this load or a line screw, and then you can touch it to the load screw as well, just to double check. Because little known fact, it actually doesn't matter which one of these screws is line or load. It does not matter. They are completely reversible. It's pretty standard that the bottom one, as far as I can tell, is your line or your hot wire coming from the house, and the top one is your load going out to the device or appliance. But it absolutely does not have to be. So just word to the wise. And if you're curious why that is, the switches are basically just controlling a circuit. So you can think of it as on and off, right? Just like a switch, you think of it as on and off. It's bidirectional. It doesn't matter which one is hooked up where, just that the two get connected or not connected. So when the switch is on, they are connected, and the circuit is referred to as a closed circuit, right? Which means power is going to flow from one screw to the other. In the case that the switch is off, they are disconnected, and you have what's called an open circuit, and power is not going to flow. So it literally doesn't matter which order you hook those two wires up in, as long as they are hooked up. That's it, right? And it's actually pretty hard to mess it up. There's very few ways. It's pretty forgiving, honestly. But the one thing I will say is you should probably do it with the idea that consistency is key. So however you hook up one up, you should probably hook the other up. And generally speaking, people expect, I think, that the bottom screw is your line wire or your hot wire coming in. So you should probably keep to that pattern. But in the case of the new switches, you'll see that they're a little different if you've noticed the pictures from before. Then this one is laid out anyway. So, I guess it really doesn't matter. But if you're hooking up a switch like this, the bottom one is generally your line, as far as I'm aware. That's usually what I've seen throughout my entire house anyway. Here you've got a nice close-up of the ground wire, and I'm demonstrating how I'm just going to take these pliers here and just pull this wire off after loosening this screw. Because you can see it's sort of bent over, and this wire is really stiff. It's not pliable at all. It's very, very stiff. And bending that out with your fingers and trying to get it with your fingers might, I mean, you could probably do it, but pliers would be more convenient. So, you know, if you have them handy, use pliers. And then I'm doing it here with this load wire, and then you can see here an image where I've got the 3 wires completely disconnected. So this is the line wire, the hot wire, and you can see the bare section where the screw was and how it just sort of continues on into this other switch. And then here you've got the ground, you can see that, and then here you've got your load wire, which goes out to, I think in this case it's the light. Or the fan. No, it's the fan in this case, because I think the right one was the fan, but it doesn't matter. Anyway, the point is that's going out to your appliance or whatever you're trying to control. Okay, so this is an image of that neutral wire that I was talking about before. You can see it's tucked way back in the back, and you can see that it's got this red cap on it. And hopefully yours is similar to mine, because that's pretty easy to work with, because you can actually just reuse that red cap. And I highly recommend you do exactly that thing. And in fact, that's exactly what I've done in every configuration of this that I've done so far, is I've just pulled that red cap off, put the 2 wires that I'm going to connect up in there, and then I screwed that red cap back down, and we were good to go. And in this case, I'm just using my pliers as a pointing mechanism to point this wire out here. But in fact, what you can do is you can actually use them to grab that wire and just sort of gently tug it into a straight position so that you can work with it. And you can see here that I've done that. Because I've got that capped off wire sort of sticking out now. And here you can see that I'm taking my wire cutters, and I'm just going to cut that wire that's going out to that second switch. Just cut it straight off at this bare wire, leaving me enough that I can screw one of those wire nuts down to it. And then I'm going to go through and just use my wire strippers and just scrape some of that excess paint off of there, just to make sure I get a good strong connection to my wires. So if I've got any of that builder's paint on there, generally the wire nuts will kind of etch into the wire, so I don't know that it necessarily matters, but just for peace of mind I do that. You probably don't have to, but it doesn't hurt. Just don't, you know, cut the wire basically, so that you don't end up with, you know, smaller wire than you can work with. That's really the only advice I can give you there. Okay, so here you can see that I'm getting ready to install this new switch here. And you'll notice these blue boxes. Those are just me sort of censoring the back of these switches. I basically am trying to hide the MAC address and the serial number of the switches, because, you know, these are actual switches that I'm installing into my wall for my daughter, and I just don't want that information on the internet. So, fun. Here you can see I'm getting ready to hook this ground wire up to the bare copper. And so I'm just going to basically gently push these 2 together so that they line up next to each other. You don't necessarily have to twist them together beforehand, but you can maybe put a small twist on them if you like. But basically you're just going to cram the cap over those 2 wires and then just gently screw them down until they don't really move anymore. So that basically screw cap will get really, really tight and hard to move. And when that happens, you can sort of gently tug on the 2 wires and just make sure that the cap's not loose and it's not going to come out. And then once you've done that, you're good. If you've done it right, the switch should generally be able to hang by this nut without actually breaking or falling apart. And here you can see I've done the same thing with that load wire. So that's our load wire going out to the fan. And the line wire, the hot wire, the line wire, you can see the end of that one that I cut earlier. We're actually going to share that with both switches. They're both going to share that. They're also going to share the neutral wire as well. And I'm pretty sure somewhere up the way, these 2 ground wires are going to meet and be shared as well. So really the only wire that is specific to each switch is the load wires that go out to the fan and the light. So really you could probably hook these things up in just about any configuration you want, and it would still theoretically work as long as you don't say hook the hot up to the ground, or the, you know, neutral up to the hot, or the ground up to, you know, as long as you don't do something like that, you're probably okay. Again, these two black wires here, those are your load and your line wires, and they are completely interchangeable. And so my only advice there is consistency is key. If you hook the second one up to your load on one switch, hook the second one up to your load on the second switch. It won't hurt anything if you don't. It absolutely will not. But I like to have everything sort of in the same order. Maybe I'm OCD, maybe I just like standards, but it's best to have everything in the same order. That way, if somebody comes in behind you and works on stuff, it's easy for them to tell what's going on. So here I am again, and I'm sorry this picture's a little bit blurry, but basically I'm hooking the line wire up for the second switch here, because I basically started on the second switch at this point. And here you can see I'm pointing out which one I'm hooking up. So the second one is our line wire, basically. So that's what's going up to that wire there. And so here you can see that I'm getting ready to hook up our neutral wires. So I've just taken that little red cap off that you saw earlier, and I've got these two neutral wires. These are from both switches. There will be one white wire per switch, and we're just going to gently sort of wrap these around this. Now, they're not going to twist on there very easily, so they don't necessarily need to be twisted on there hardcore or anything, but just sort of gently butt them up next to it, and maybe give them a little twist as best you can, but don't worry about it if you can't get them twisted on there very well. I generally don't twist them on there very well. I just kind of let them lay next to it and then screw them down, and it works just fine. So here you can see I'm going to do the same thing with our line wires. So this is our hot. I'm just going to gently put those on this line wire, and it's kind of blending in with our load wire for our fan here, I think, or whatever device it's going to. I can't keep it straight anymore. But anyway, this particular wire is kind of blending in with this black wire, but there's a black wire here that I'm butting this up to. And you can see they're hooked up now. So this is our neutral wire here. It's going to each switch, and it's hooked up to that bundle right there. And you can see this one is our line wire. So this is our hot, and it's coming in next to our neutral. Then you've got your two load wires, which are going to the other black wire, which are next to the ground here, right? So you can see that, hopefully. This one's going up and snaking up here, and then this is the red wire connecting up. This one's coming in from this guy here and going to that one that's next to the white wire over there. So hopefully that's easy to follow, but I know the picture's a little and then you have your grounds hooked up to the bare copper, and that's pretty much that. So at this point we're hooked up, and you can kind of start gently pushing them back in. So what I've done is I've just used my adjustable plier wrench thing here, and I'm going to gently push that back into the box up against the back of that box there. And at this point, it may be wise to go down, go back to your, I almost said downstairs because I was totally working in an upstairs room in this case, but go back to your breaker box and find your breaker and flip it back on with the switches still kind of semi-exposed, and just test them to make sure they work. Make sure you're very careful not to touch any of the wires, at least any of the bare wires. Like if you touch the shielding or the insulation on it or whatever, you're fine. That won't shock you, but I would still be careful anyway, and probably just touch the front of the switch and just gently, turn the light on and off, and just make sure things are working before you go through the effort of pushing everything back in there and buttoning everything back up. Because if something doesn't work, you'll thank yourself for testing it first. And then before you push everything back in, go back to your breaker and turn the power back off. You can retest with a multimeter if you want, but your wires are generally kind of buttoned up at this point, and there's probably not a lot of bare wire for you to touch. So really the only way you'll be able to test is to cram your little multimeter lead up underneath the cap, which you might not want to do that for risk of loosening the cap somehow, or whatever. But if you did want to test it just to be extra safe, that's how you would do it. If you've done everything right, all of your wires should be covered at this point anyway, and nothing should be at risk of shorting or being touched without removing the caps. But safety first, right? So just be careful if you're working under what we call a load. And so once you're sure that your switches work and you're good to go, you can push these switches back in. I've got some more masking on the switch here. That's because you'll notice that there's a MAC address on these switches on the front. And speaking of which, the orientation for these switches should be text up. There's also some up arrows, I think, on the back of the switches when you first had those face plates on. But, you know, that's the orientation for the switches. So when you're mounting them back in, make sure you're mounting them text up. And the MAC address will be at the top of the switch if you're using this particular model. And then basically these switches work like toggles, so there isn't like an on-off position. It's more like a button that you're going to press, and you're going to press it at the bottom. Now that's just these smart switches. Other smart switches may vary. So if you buy different ones, obviously you may have a different experience and a different configuration. So just be aware of that. And here is a view of them with them both sort of in. Now you may want to leave these screws slightly loose so you can kind of finagle them a bit, because when you put that cover back on the first time, you may notice that they don't line up perfectly, and you may want to sort of maybe just gently move them around a little bit before screwing them down all the way so you can kind of line them up. One trick you can do is take a flathead and sort of push against the wall here just gently and nudge them over. And you can do the same on this side for this one, and then you can kind of nudge them in the middle there. Just be careful that you don't push so hard that you damage your wall or that you ruin the plastic around the edge of your switch. And then once you've done that, you go turn your breaker back on, and you should get these little emblems here, these Wi-Fi symbols on your switches, and that means they are good to go and ready to pair. It may have also have been a good idea to take a note of those MAC addresses so that you know which switch is which. So if we go back, okay, so here there will be MAC addresses. You may want to note down the last few characters of the MAC address. Usually the last two is probably sufficient. You generally don't need to write down the whole thing. But just note, especially if they're different on the last two, which one is which, because that's going to be which one goes to your fan and which one goes to your light. And as long as you've kept track of which one those are, then when you pair them in your app, you'll know. Otherwise, you'll need to rename them or whatever when you get done with the pairing. So this is a screenshot of what the app actually looks like. And to add a device, you're going to go to your devices here, and you're going to go to this little plus sign. It's going to bring up a little wizard and walk you through the process of adding a device. It's pretty straightforward. Basically, it's just going to ask you if you want to connect to a switch. You're going to say, yes, I'm ready to do so. Yes, it's blinking with the red light flashing, or the whatever light's flashing. It's going to scan for your switch. It's going to basically create a Wi-Fi connection with your switch, and then it's going to give you the ability to connect it to your Wi-Fi network. So you're going to tell it what network you want to connect to, and then you'll connect back over to your normal Wi-Fi network, and then you'll notice your switch has been added, and you can talk to your switch via the app now. You'll be presented with the option to give it an icon and that sort of thing. Now, granted, this is just with the Casa app for the TP-Link stuff. If you're using a different system, your mileage may vary, obviously. But that's a very brief demonstration on how to actually add the switch. I didn't actually want to go to a very detailed explanation of this because these kind of will be quite different depending on the different switches you get. And it's very straightforward. They go like out of their way to make these apps pretty easy to use. And I felt like this one was pretty trivial. It wasn't too bad once I got in there and started messing with it. Lastly, this is the back of a two-way switch. So the box that I showed you, or a three-way switch, sorry. The box that I showed you in the very beginning is a three-way switch, and you'll notice this one looks a little different. Rather than having leads or lines coming off of it, it only has these two coming off. So you got a neutral and you've got a ground, and these will both require a neutral wire. So yes, these still require that neutral wire. You're not getting out of it just because you're using a three-way switch. Your line load is here, and you have these new wires called traveler wires. These are unique to having a three-way system. So I'm going to go ahead and show you guys a diagram and explain how a three-way system actually works. But this is a very close-up view of the back of one of these switches. So you can see here that I've given the back of two of these switches. And so this is sort of basically the exact picture that I showed you earlier, but it's been rotated, and now I've got some diagramming coming off of it. So you can see here we've got our load line, or our line wire coming in, and it's going into your primary switch. And you'll notice you have a primary and a secondary switch in this configuration. Now, the difference between your primary and your secondary switch is your primary switch is where your power actually comes in. Your hot is going to come into your primary switch. Your secondary switch is where your load is going to go out to your device. So on your secondary switch, that's where you're connecting up to, say, your light or your fan or whatever it is you're dual switch trying to control with dual switches, okay? And it is your travelers that actually determine whether or not this device has power, okay? Because basically what's going to happen is when you flip one of the switches, it's going to flip which traveler has power going to it. And that's how the switch will determine whether or not to output power to this line wire or this load wire. So you can see here I've got these labeled. I've got my line wire, I've got my neutral wire. Now your neutral wire is going to be white, but white obviously wasn't going to work too well with this particular background. So I use this dashed sort of line instead to indicate the neutral wires. So hopefully that's not terribly confusing. I've also used this red wire to indicate the load wire so that it stands out more. It may be black for you. The line colors are not necessarily representative of what you might find in your box. Your traveler wires, I've made them gray just so that they look different from the other wires, but they are probably going to be colored black or maybe have splattering of white paint all over them, much like your other wires are. So my recommendation for you here is just be careful and make sure that you get your traveler wires. Make sure you pay attention to what you're unhooking from your other switch before you do it. So what I would do is generally I would take a picture of the switch in its original configuration so you can always fall back on how things were originally hooked up. Your traveler wires will switch polarity, or I don't know, polarity is kind of the wrong word. They'll switch which one is hot and which one is not, basically, based on the toggling of your switches. So if you get confused about what wire is what, leave the power on after you've pulled, go to your box, turn your power off, pull your switches out. Always pull your switches out with power off, okay? And then use a multimeter to test your load line wire and see if it has power or not after you turn the power back on, okay? If your wire has power, then what you're going to do, if it has power, then you know that that load line wire is the switch A, or the primary switch, okay? So if you have power coming from this guy, then you have your primary switch will be your primary switch, okay? You may notice power coming from your traveler wires, and generally your traveler wires will have a different color. So you'll notice here this one is black and these two are like a brass color or a copper color even. I think it's actually more brass, but anyway. So the screws should be different for the traveler wires, and that was true in my house. So when I looked at my original switches, I had two different colored screws for the line load wire and the traveler wires. The traveler wires are both like a brassy copper color, and the line load wire was black colored. Remember, when you use a multimeter, you're always going to want to hook it to your ground first. So you should have a ground screw on your original switch, or at least a bare copper wire sticking out of the wall somewhere. Just touch that with your black lead, and then use your red lead to probe your line load. If you see values on the front of your multimeter, if you have it configured correctly for your house, 120 volt, remember you're going to set it at 200 setting. If you have it configured that way, you should see numbers on that thing pop up, and it should get close to it. It doesn't necessarily have to reach 120 or be 120 exactly, but it should be within that ballpark. And if it is, that's your wire that is hot. Now you may see that one of your travelers is also hot if it's still hooked up to the switch, and that's because those wires will switch from one to the other depending on what position your switch is in. So if you flip your switch from off to on, you'll notice which one of those two travelers is hot will change, and then when you toggle it the other way, it'll change back. And so if you notice that, you are on switch A, okay, or the primary switch. If your line load wire is not hot while your power is on, then you are probably on your secondary switch. Your traveler wires, however, one of them will always be hot if they're hooked up to your primary switch, because again, when you switch your switch, it's just going to toggle which one of these has power. And then your secondary switch over here is going to control whether or not you've got power coming out to this guy. Now, here's the cool thing, okay, about these switches. You do not have to use both of them, right? You do not have to make both of your switches a smart switch. So when you buy these things, you'll get a pack of 2, but you do not have to use both. You can leave a normal dumb switch on one of the 2 switches, and it doesn't even matter which one it is. So it can be your primary, it can be your secondary, it does not matter. The only trick is you need to make sure you don't get confused about your traveler wires and your load line wire. If you do get confused, you're not going to burn your house down, but what will happen is when you flip your switch, you may not notice that it cuts off properly or that it turns back on properly. So you may notice that your light switch is, your light is always on, in the case of this switch being on, or always off, or you'll get weird behavior like that. But it generally will work and it will not burn your house down if you hook your load wire up to the wrong thing here. I have not checked to see what happens if you hook your line wire up to one of these traveler wires. I suspect nothing, and it will just keep them completely hot all the time. But I don't know. I don't recommend testing it. I would definitely recommend you just get it right if you can, because at the very least, it's not going to work the way you want it to. I don't think it's dangerous necessarily, because power does go through there anyway, and they're just switches. But, you know, abundance of caution, right? Always operate with caution. So your neutral wire and your line wire will generally go back to your circuit breaker. And I think actually technically your ground goes back to your circuit breaker as well. But I've drawn them this way so that I didn't have these ground wires just wrapping all over the place. I wanted to make it so that I didn't have too many wires jumping across things so that it didn't get too confusing to look at the diagram. So I've just kind of drawn them going off to the ground. But I think in actuality what they do is they go back to your circuit breaker, and then from there they go to your to a rod that goes down into the ground. So that is basically how they work. So again, you will need to make sure you have at least one of them needs to be hooked up for, you know, the smart switch system to work. But if you don't hook up a second one and you just leave the second switch dumb, you still can control the light using your voice controlled system just fine. They will toggle off and on, and if you hit the other switch, it will toggle off and on correctly as you would expect. The dumb switch will just remain dumb, and it doesn't even matter which one, of course, like I think I said this before, but it doesn't even matter which one of these becomes the smart switch. You can hook them both up if you want, but there are reasons not to. Number one, your money will go further because you can use both switches. If you have multiple places in your house where you have three-way switches like that, you can use both switches that come in the box on both of those points, and then you've gotten, you know, more bang for your buck because now you've made 2 systems smart instead of just one. Another thing to be aware of is, in my case, I had a switch in my staircase where switch B, or the secondary switch, did have the neutral wire behind it, but the first one, the primary switch, did not. And so what that meant is that I was unable to make the primary switch a smart switch, and I was forced to use just the secondary switch as the smart switch. Now again, as I stated before, that absolutely does not hurt anything and has no bearing on which one of these becomes smart or not, or whether or not the smart switch will work. It will work just fine with just one switch, as long as that one switch has a neutral wire like it's supposed to. So if you go in on your 3-way switch and you notice one of them does not have a neutral wire, do not panic. Just leave that one dumb and hook the other one up, provided it does have a neutral wire. If neither of them have a neutral wire, you're kind of out of luck at that point. You need that, at least with these particular switches. So you're probably going to have to do some homework and figure out what to do if you don't have a neutral wire, or you know, hire an electrician to come out and fix that for you if they can, or find a switch that works without a neutral wire. But in any case, that is how a 3-way system works, and I hope that sort of alleviates the mystery for you a little bit. I know that's not as good as actually showing you the pictures for the 3-way system like I did with the prior stuff, but you know, I hope that it still works out well and that you're able to make it work, you know, provided you follow the instructions. For me, this was the missing piece, actually. So I had to watch a lot of different videos to try and accomplish this, one of the most difficult parts of it was figuring out whether or not I was at the primary switch or the secondary switch, because I was operating under the assumption that I was at the primary switch when I first tried this, and it threw me off really, really badly. So once I saw this wiring diagram and realized what was actually going on, it clicked. It just made it so much easier for me to figure out. So hopefully seeing it like this will help you. That's it. That's the end of the show. I hope you guys really enjoyed it, and good luck on your project.